2.1 defining polynomials. So this entire unit has to do with polynomials. Consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponentiation of variables. Okay, so that's a big mouthful. To kind of summarize this, I'm just going to add a couple things, just kind of summarize it below. So it says addition, subtraction, and multiplication. So that means no division. So I'm going to write no division underneath here. So we can't have division within the terms for it to be a polynomial. Okay, so no division. And it also says non-negative. Let me highlight this because it's kind of confusing. Non-negative integer exponentiation of variables. So the exponentiation, that just means exponents. So what this is saying is that exponents must be positive integers. Must be positive integers. It says non-negative integers. So they must be, if it's non-negative, it must be positive, and it must be an integer, meaning we can't have like fractions or decimals for the exponent. Okay, so let me do a few of the multiple choice here. So these multiple choice questions say this. They say, which of the following is not a polynomial? So the answer here would be B, because we see that division. We have 2a to the second divided by 3b. That's not considered a polynomial. It needs to be written like the other ones show. Number 2 says, which of the following is not a polynomial? And we're saying not. And this answer is going to be D. Because look, right here, let me circle it in blue or something. Negative exponent. See, it says -1. That's bad. Can't have a negative exponent if it is a polynomial. Number 3, which is not. Again, these are all saying which is not. Whoops. That would be A. Because you can't have fractions as an exponent. It must be an integer. You see it has a 1/2. So that is not a polynomial. You can have fractional coefficients. So like C is fine because that 3/4 is not an exponent. But A is not good because you have a fraction as an exponent. You can't have fractional exponents. You can't have negative exponents. That's not considered a polynomial. So I'll let you do number 4, and then you can kind of come up with your own too for 5 and 6. So as we kind of name polynomials, when we're speaking about polynomials, we'll be using like these sort of terms: a monomial, a binomial, a trinomial. So a monomial is a polynomial with just one term, a binomial has 2 terms, and a trinomial has 3 terms. And we also define polynomials by the degree. The degree of a polynomial is the same as the term with the highest degree. So let's first look at 7a. It says, classify the following polynomials based on the degree and the number of terms. And degree is just the exponent. Now, let me write that. Degree, this is like your exponent. So 7a, we have 4z to the 7th. So the exponent is 7. So this is a 7th degree. And there's only one term. Terms are separated by like addition and subtraction. So there is no addition or subtraction here. There's just one term, the 4, so 4z to the 7th. So this is a 7th degree monomial. Now B has 3 terms. So we know it's going to be a trinomial, but we need to first figure out what the degree is. Now remember when we define polynomials as degree, it says it's the same as the term with the highest degree. So this is 3 terms. The 3x to the 4th has a degree of 4. The x to the 10th has a degree of 10. And the 5x to the 3rd has a degree of 3. So the highest one is the 10. So this is a 10th degree trinomial. C is just a monomial. Remember, terms are separated by addition and subtraction. So although you see an x and a y, this is still just one term. And the degree of this term is those kind of combined exponents. So 9 plus 2 is 11. This is an 11th degree. Monomial. There's only just one term. That's just a combined, that's one term. D has two terms. Maybe I'll highlight the two terms just to make this as clear as possible. Those are our two terms. The degree of the 3x2y3 is 5 because 2 plus 3 is 5. So that part's that's fifth degree. Now the yellow highlighted 9x4z2, that's a sixth degree because the 4 and the 2 combine to 6. So we picked the higher one. So we have the 5 and we have the 6. This is 6, so this is a sixth degree. And there's only two terms, so I'm going to call this a binomial. Okay, I'll let you do the rest of those. Standard form. For a polynomial to be written in standard form, you must reorder the terms so the degrees of those terms go in descending order. So that basically means you need to rearrange the terms so that the exponents go from highest to lowest. So on A, I have 3x to the fourth, I have negative 5x to the third, and I have positive 9x to the seventh. Those are the three terms. Remember, we have to go from biggest to smallest when we rearrange them. So the 7 is the largest degree. So the 9x to the seventh goes first. The 4 is the next biggest. So the positive 3x to the fourth goes next. And then the minus 5x to the 3 goes last. It's now in standard form. Again, we're just looking at, we need these to go from biggest to smallest, the exponents. Has nothing to do with the coefficients in front. The 9 meant nothing, the 3 meant nothing, the negative 5 meant nothing in terms of the reorder. It's about the exponent. So you're shifting, moving the terms around. You can do B and C. Couple more vocabulary words, coefficients and constants. So the definition of the coefficient is the number in front of a term that is multiplied to the variable. So it's that number in front. And the constant is the term, or generally or always, it's just like a number that does not have a variable. So that's going to come into play here. So number 9, we got consider the polynomial 40 minus 2x to the 9th plus 7x to the 5th. Letter A says write the polynomial in standard form. So we need to put the term with the biggest exponent first. That would be negative 2x to the 9th because the 9 is the biggest exponent. The 40 doesn't even have a variable. It's got no exponent. So the next term would be 7x to the 5th. And then positive 40 would be last. So that's it in standard form. So as we do the rest of this, we're going to be looking at this now written expression in standard form. So we're going to kind of ignore this now, and we're just going to look at what we have in standard form. So the question says, what is the degree? So what is the highest exponent? 9. This is 9th degree. 9th. What is the leading coefficient? So leading's like in front, right? And our coefficients, we have a couple of coefficients. We have that negative 2 and we have the 7, right? Those are the numbers multiplied to the variables. So the leading coefficient, the one in front, would be negative 2. That's the leading coefficient, the leading number in front. What is the number of terms? There's 3 terms. The negative 2x to the 9th, the 7x to the 5th, and the 40. 3 terms. What is the constant term? So the constant term is defined as the term that doesn't have a variable. That's 40. That's the only of those terms that doesn't have a variable. That's the constant term. All right, so I'll let you try 10 and 11. And that's defining polynomials.